In section 1.2, we're going to work with literal equations. So a literal equation has more than one variable. You definitely worked with a lot of these in geometry when you did surface area and volume, so all those formulas, you'll see these a lot in science classes or like a physics class. Basically what this means is you have more than one variable or more than one unknown. So a common terminology here would be something like saying solve for y in terms of x. So if you read something like that, that would mean here in this scenario to get the y by itself. So it's important to know how to read those. So in our first example, let's look at a temperature equation. The equation C equals 5 over 9 F minus 32 converts degrees Fahrenheit to degrees Celsius. So this equation is super helpful if I have degrees Fahrenheit. So like for example, today it's 80 degrees out. If I wanted to convert that to Celsius, I would just plug in 80 for F and it would spit out what that converts to in Celsius. But what if I was given Celsius and I wanted to convert to degrees? That's where solving for a literal equation would be helpful. So what I would do here is I would want to find F, or degrees Fahrenheit, in terms of degrees Celsius. And what that means is get F by itself. So I'm going to rearrange this equation to make it helpful for if I was given Celsius, wanted to find Fahrenheit. So what I want to do here, again, is I just want to get the F alone. So first I would deal with that fraction coefficient to get rid of the parentheses. How I always like to do these is to multiply by the reciprocal. So I'm going to multiply both sides by 9 over 5. And what's going to happen when I do that is on the right, that fraction is going to cancel out. Now I have 9/5 C equals F minus 32. And then finally, to get that F by itself, I'm going to add both sides by 32. And I'm left with F equals 9 over 5C plus 32. And again, this equation would be really helpful if I'm given degrees Celsius, but I wanted to find Fahrenheit. I could just plug in Celsius and it would spit out degrees Fahrenheit. One last example, then we'll call it a day. We have S equals 1/2 GT squared, and I want to solve that for T. So what I'm going to do here first, everything that I see on the right with that T needs to move to the left. First, I'm going to get rid of that 1/2 by multiplying by its reciprocal, which is 2 over 1, or just 2. So now I have 2s equals gt squared. I'm going to divide both sides by g. And then finally, to get that t by itself, the opposite of taking something to a power is to take the root. So here, the opposite of taking something to the second power or to square something is to take the square root of it. So I'm going to take the square root of everything, and I'm left with t equals the square root of 2s over g, and I'd be done. Now keep in mind here, these problems sometimes feel a little bit tricky because typically when we solve equations like we did in the 1.1 video, it's kind of satisfying to see terms simplifying and us combining like terms, and with each step our equation gets a little bit smaller and more simplified. You don't have those in literal equations, but just keep in mind that your goal here is just to rearrange the equation. You're not solving for a number, you're not finding a value, you're just rearranging an equation. So your final answer here is going to be another equation. It's not going to be some simplified number. So yep, so number 2, that'd be my answer, and I'd be good to go. I'd be done.